So, Assalamualaikum warahmatullahi wabarakatuh. So, my name is Daniel Haziq from Group 3 and my group member is Daniel Rafiqi. So, we want to present a project assignment, the frequency assignment around 1.0 to 1.5 gigahertz. So, in this project, the measurement tools used in investigation is a spectrum analyzer. So, a spectrum analyzer is a device that measures and displays signal amplitude strength as it varies by frequency within its frequency range spectrum. The frequency appears on the horizontal x-axis and the amplitude is displayed on the vertical y-axis. So the spectrometer can be used to measure frequency response and noise distortion, occupied bandwidth, and interface source, and pre-compliance testing. So the procedure in collecting the data or guideline used to perform study. So first, we attach the antenna to the top of the spectrum analyzer, and then we press the green open button to open the spectrum analyzer. Next, we set the frequency, set start and stop frequency, and then press the fragment menu submenu key, and then we press the start frag submenu key. So after that, we set the frequency at 1.0 GHz and press gigahertz submenu key. After that, we press the stop frag submenu key. So set the frequency at 1.5 GHz and press gigahertz submenu key. So the last step, we press a marker to see the strength frequency. So we find frequency at 3 different locations around the campus. So first at the masjid, and second bangunan BN, and third location bangunan BN. So first location result, here we don't see a slightly high frequency or high peak in this area. So probably because there is not much frequency signal noise in this area around 1.0 to 1.5 GHz. So we try changing the frequency to 2.4 to 2.6 GHz around this area to see if this place has a high peak. So what we can see here is one or two high amplitude that we can take in this area. So next, second location result at bangunan BM. So what we see here, that area also does not have a relative high peak using frequency 1.0 to 1.5 GHz. Because maybe it's probably also less frequency signal noise. So again, we try change the frequency to 115 megahertz to 1000 megahertz. So what we can see here is one is around 4 high peak high amplitude that we can take in this area. So we pass to Daniel Rafiqi to continue.
Okay, now I am Muhammad Rafiqi. So I will start presenting from the third location result, which is from BM building. As you can see, we only had our frequency is 1.0 gigahertz to 1.5 gigahertz. As you can see, our frequency does not produce the optimal signal that we want. So we made a comparison with our friends group, which their frequency is 650 megahertz to 850 megahertz, which they they gain their optimal signal, which their amplitude is higher than us. So for the next slide is the limitations and problem encountered during the investigation. Our frequency value does not produce the optimal signal. It is as before you've seen. And the second one is waiting for our turn to use the spectrum analyzer, which will be quite a problem because there are many groups, but the spectrum analyzer only have one item. So the third one is using wrong averaging type. We sometimes at one signal at one place we only did it 2 times to get the signal. So to get the optimal signal, we should have done 4 times. For the first reason is not synchronizing measurements with operation complete OPC flag. So the third is the standards and technical specifications referred. The first one is must have a wide resolution bandwidth, which is required for wide sweeps while a narrow field is used for narrow sweeps. The second one is the spectrum analyzer should have 10 MHz to 2.4 GHz range, which includes our frequency value, which is 1.0 GHz to 1.5 GHz. And the third one is the spectrum analyzer must be calibrated regularly to ensure valid test results. The fourth one is the signal sensitivity, and the fifth one is amplitude accuracy. This is to detect the signal more precise because signals can be many types. Okay, that's all from us. Thank you.